Hey guys, Miss Michelson here. Today I'm filming a video going over the topic 10 review over circles. And I've got my calculator nearby because I know I'm going to need to use it in some of my problems. But for the first set of problems, all we want to do is label parts of circles. So we've got some definitions right up here that we want to know and be able to find in our circles. And the first one is a radius, which I know starts at the center of my circle and goes to the outer edge. Can label that R. A chord has two endpoints on the circle, but doesn't go through the center. The diameter has two endpoints on the circle and goes directly through the center. A secant is a line that cuts through a circle and it intersects at 2 points. And a tangent is a line that is on the outside of our circle that intersects at 1 point right here. So we've got radius, chord, diameter, secant, and tangent. And then my next kind of line of boxes are all having to deal with arcs. A minor arc is an arc that measures less than 180. So you could draw as many arcs in there as you wanted. A semicircle is half of a circle or half of an arc right here. A major arc is an arc that is greater than 180. So for this example, if I had these 2 points labeled here, the major arc is this big arc right out here. Whereas opposed to the minor arc connecting those two. A central angle is an angle that starts at the center of our circle. And an inscribed angle is an angle whose vertex is on the circle. So notice the location of those angles are different. All right, section number 2, equations of circles. The first thing that I'm going to write out here is the standard form of the equation of a circle. And we're going to use that to help ourselves answer these questions and some questions on the back. I'm actually going to start with number 2 here, and then we'll go back to this problem right over here. So what we want to do is identify the center and the radius of the circle in order to graph it. And the center and the radius can be found just by looking at the equation. So the first thing I'm looking for is something in the place of this h, and I see I have a -1. That means the center has a point at +1, or the ordered pair, the first letter or number is 1. The second variable that I have is k. This is a +3, so in my center it's a -3. And then this last one I think is the one is the trickiest. This is my radius, but this is my radius squared. So I'm going to write out the equation r squared equals 4. And then I have to take the square root of it. The square root of 4 is 2. And with that information, I can go ahead and graph my circle. The center is over 1, down 3. And then it has a radius of 2, so I'm going to go over right, up 2, left 2, and down 2. And that's enough for me to draw in my circle. Now this question over here is working backwards. We're given the picture of the circle, and we want to find the equation or write the equation here. So the first thing I want to do is find the center, and I notice that that's at the point over 0, down -1. And then I also noticed that the radius is 1, 2, 3, 4, 5 units long, and I just got that by counting. And now we're going to work backwards with our x value, our y value, and our radius. And we're just going to follow along with this formula right here. So it tells me to do x minus h. H is 0, so x minus 0 squared, plus y minus k, which is -1 squared, equals my radius squared, which is 5 squared. Now there's some cleaning up here that we can do. X minus 0, we don't technically need to write out that -0. So I'm just going to write this as x squared. When I have a double negative in math, it turns into a positive, so it's going to turn into y plus 2 squared. And then 5 squared is 25. So this is my final answer. And we're moving right along. I'm going to flip over to the next page. At the top of this page again, I'm going to write that equation out. X minus h squared plus y minus k squared equals r squared. And then these two problems are just like the problems we just did. We're given the h, k, and the r, and we just had to plug them in. So I'm going to go down my row, x minus h, which is negative 8 squared, plus y minus k, which is negative 10 squared, equals r squared, which is 15. Now we can clean this up. Double negative turns into a positive. Double negative turns into a positive. And 15 squared is 225. And there's a few things that we can point out here. Remember how we said that the center in the equation should switch signs? So these negatives should turn into positives, and that's exactly what we see. And then we just had to remember to take our last value and square it. So a lot of times I feel like some of us skip over writing out this step right here, which is totally okay as long as you're prepared to flip your signs. So that would look like just starting off with my equation, x. This is a minus 11, so I'm going to turn it into a plus 11 squared. This sign is always going to be a plus sign. And then I'm going to have y. This is a positive 18, so I'm going to subtract 18. And then the last thing I want to do is square my radius. But 1 squared is just 1 times 1, which is equal to 1. So that's kind of funny. But that's my final answer. So write out this step if you want to, but remember you don't have to. My next kind of section of problems are all of our angles in our circles. So we should be prepared to see one of each type of these questions on our test. And I feel like the first one, well, it's a little tricky, but the first one's not too bad. So the first thing that I notice is I'm given this 29. And I know that this angle measure here is 29, or not angle, this arc measure is 29 because this is a central angle. But if I look at what the problem's asking me to find, this is a major arc. We're going from X to Y to Z. We want to find everything on the outside of that circle. So my answer is not 29. I got to remember that the total of a circle is 360, and then I'm going to subtract 29 from it. So in my calculator, 360 minus 29 is 331. And that's my final answer. Question number 2, or the one in the second box, we're trying to find this measure right here. Notice that the angle or the vertex of our angle is located on the circle. So this is the relationship where you just have to double the angle. If this angle is 82, to double it, I just multiply it by 2, and I get 164. The next problem looks almost the same. We have an arc measure. This time we're trying to find the angle with the vertex on the circle, but we're going backwards this time. We're given the big value, we want to find the small one. So instead of multiplying by 2 like we did in the first one, here we're going to divide by 2, which equals 100. And then our last ones here was the last little bit of topic 10 that we did. The one thing we want to remember or want to look at is where our two lines are intersecting. And that's going to tell you whether or not you add or subtract. I always remember that when they intersect inside the circle, we add them because they kind of look like they make a plus sign. So that's how I remember. Technically, our formula is angle equals half of the arc plus the arc. And my two arcs that I know are 80 and 146. So I'm going to plug those in. 146 plus 80. At this point, I probably would type that whole thing into my calculator, but I feel like you all like to do it step by step, which is probably better. So I get 1/2 of 226. A lot of people are like, how do I put this in my phone calculator? The easiest way to do that is just to take 226 and divide it by 2. It's going to give you the same thing. 113 is our answer there. Now, our middle problem, if we notice, looks a little bit different than the two end ones because the angle here is on the outside. So if the angle's on the outside, we have the same formula, except for we subtract them. So it's going to be a minus sign this time instead of a plus sign. So I get to fill in my values. And then we also have to be careful. We always have to do the big arc minus the small arc. So I'm going to do 120 minus 50. And that's going to give me 1/2 of 70. And half of 70 is 35. So my angle measure there is 35. And then last but not least, this problem right over here, we're back to our adding ones. The angle equals half of the arc plus the arc. 85 plus 55. 85 plus 55 is 140, and half of 140 is 70 degrees. So there's my second page done, and we are on to the last ones. If we flip over, our next section is our segment, our tangent segments in a circle. And the one thing we want to remember is that when things are tangent, they form 90-degree angles. So this question is really asking, is this a 90-degree angle? And we have two ways that we can do this. And one way is given the side lengths. And we're going to want to use the Pythagorean theorem. So we want to ask ourselves, is this true? So if I look at what I've got in my picture, I know that one of my side lengths is 10, the other side length is 12, and then I'm given this 5. But this 5 represents from here to here, and that's not the whole length. So we got to do a little bit of reasoning here. From B to C is 10, and it's the radius of our circle. And the circle has the same radius all the way around. So this distance is also 10, making that whole thing 15. So this is what we get to check right here. And I like to put these into my calculator as well. I'm going to do 10 squared plus 12 squared. Oops. And I'm going to get 244. And I'm comparing that to 15 squared, which is 225. This statement is not true, so it's not tangent. Not tangent. We could circle no. Let's make ourselves a note that we did this when we had our side lengths. We used the Pythagorean theorem when we had side lengths. But if we look at number 8, this one, we want to say if MP is tangent. So this triangle actually over here is unnecessary. Now we're not given the side lengths, we're given the angle measures. Well, if we're checking to see whether or not this is a right angle, we want to check to see if that's 90 degrees. So the way I can do that is I'm going to take 180 and I'm going to subtract the two values given to me in my problem. 180 minus 58 minus 33. And I get that this equals 89 degrees. So that angle is 89, which means it is not a right triangle. Therefore, it is not tangent. So this strategy using 180 is when we're given the angle measures. And then the last thing we have on our paper is a nice little puzzle trying to solve for some things. So the first thing I want to do is find the measure of AEB, this right here. And I don't know anything about it, but I do have this 68, and I notice that they're making a straight line. And I know straight lines add up to 180. So if I subtract 68, 180 minus 68 is 112. This angle right here is 112 degrees. The next thing I want to answer is the measure of the arc AB. So this arc we know is related to this angle when E is the center. They have the same values. This is going to be 112 degrees as well. Now, the next part that we want to find is BC, the arc right here. And this is similar. If that angle is 68, then my arc BC is 68 as well. And then next we want to find, trying to find a different color. Next we want to find DC, this right here. And I notice that it's formed by this angle, but I don't know anything about it. So I'm going to have to use a different strategy here. And one thing I recognize is I know this chunk of my circle, I know that chunk, and I know that chunk. So all that I'm missing is technically the segment or the arc measure DC. So again, I'm going to use the total of my circle, which is 360, and I'm going to subtract all of the pieces that I know to find what's left over in green. So I'm going to do 360 minus 126 minus 112 minus 68, and that's going to give me 54 degrees. 54 degrees. And then last but not least, I want to find the measure of DAC. That's this right here. And we've done problems like this before, but this one's kind of tied up in a puzzle. What's the relationship between the arc and the angle when the vertex is on the circle? It's half. So all I have to do is take 54, divide by 2. I think it's 27. 54 divided by 2 is 27 degrees. And these are my 5 answers here. And that's the end of my review. If you all have any questions for me, just let me know. Hope this helped.